In this video I'm going to develop the Pythagorean Theorem. So Pythagoras, being a very smart man, he saw that when you have a right triangle and traditionally labeled with sides of the legs of the triangle, these two that meet at perpendicular angles, or right angles, they're perpendicular to each other, traditionally labeled A and B, and then the hypotenuse, of course, the third side, the longest side, would be C. The reason also for that is that the longest side is always across from the largest angle. And when we know that the three angles that are added together, the three interior angles of a triangle, those interior angles, write it down here, angle A plus angle B plus angle C, those three angles added together in a triangle will always add up to 180 degrees. So if one of those angles is taken up by 90, so angle C is taken up by 90, well then that means, so if we know that's 90 degrees, then we know if we take that 90 out of consideration, we're going to take out the 90 from the other side as well, because it's an equation, and we have to do the same thing, of course, to both sides of an equation to keep it balanced. Then angle A plus angle B must equal 90. And if two of these angles, angle A and angle B, if two of these angles add up to 90, then there's no way that either one of them can equal 90. Which means then that side C is going to be the longest side because it's across from the largest angle, and then whichever happens to be the shortest side, in this case it's A, this short side is across from the smallest angle, and then the second longest side will be across from the angle in the middle, the medium size angle. Okay, so that's just another little addition to this. So we know that C, the hypotenuse, is the longest side, which I like to call L for the longest side. I know people like C, but C doesn't mean anything. They just label it ABC. So I'm labeling this L as the longest side. I'm going to label A as the shortest side, so I'm going to label it S, and I'm going to label the medium size side as M. So getting back to Pythagoras, he saw somehow that if you're to draw squares off the sides of each of a right triangle, then the area of each of these squares, and this is square of side length S, which the area would be S squared, because length times width gives you the area, and if both sides are the same length, then it would be S times S, which is S squared. And we draw, sorry, I'm in mid-sentence here, but we draw the square off the medium size, it's medium side as well. And so this is, of course, a square. And so if we find the area of this very specific rectangle, where all the sides are the same length, then the area of this rectangle is length times width, but because it's a square, it's a special type of rectangle, it's a square where both the length and width are the same dimensions, then it would be m times m, which is just m squared. And we do the same thing for the longest side on the hypotenuse. And we draw a square off this longest side again. And then the same process continues. We've got the square off the longest side of the triangle, and that area is L squared. So, getting back to my original sentence, Pythagoras saw that if you take the area of the two smaller squares, they will add up to the area of the larger square. And there are many videos online that show this, whether they use post-it notes or computerized squares that kind of rearrange together and form the larger square in many ways, or the larger square will come apart and fill the two medium-sized squares, or the small and the medium square. Either way, this forms Pythagorean Theorem, which is L squared equals S squared plus M squared. So the area of the square off the largest side, the hypotenuse, is equal to the area of the square off the shorter side plus the area of the square off the medium side. So when we look at it as squares, and we know that the area of this square plus the area of this square will add together, those two areas will add together to give you the area of this square, then if we're given the lengths of the two legs of the right triangle, then we just square those, because each of those legs are the dimension, or is the dimension of the each of their individual squares. We can just add those two areas together to get the area of the larger square. And then if we know the area of the larger square, well, to then go from the area to the side length, if we know the area of the larger square, we want to go to the side length, then in order to do that, if we take the square root of the area of the larger square, then that just gives us the length of the side. Okay, so that's just a way of going from the area of the larger square to get then the length of the side. And then once we do that, once we find the square root of the area of the larger square, that gives us the side length of the square, and henceforth it gives us the length of the hypotenuse of this triangle that we're talking about. And I'm sorry, I should have originally drawn this in red or highlighted it in some other way so that we could identify the right triangle a little bit easier. Okay, so that being said, there are times when you're working on problems and you will get the two side lengths, the lengths of the legs, and you have to find the length of the hypotenuse of the triangle. So you then take the side length S, square it, you take the side length of M, square it. That gives you the areas of these two squares off the legs of the triangle. You add them together, you get some value that equals the area of the larger square. And then once you know the area of the larger square, you'll take the square root of that, and then the square root of L squared. So the square root and the squared cancel each other out. Basically, they do the opposite, they're opposite operations, and that gives you the length of the side length of the square. So if we know that the two areas are added together, the two areas of the squares off the legs of the triangle, they're added together to give you the length of the larger triangle, or the square off the larger triangle, or the larger side, sorry about that, then if then we're given in a different type of problem, if we're given the length of the hypotenuse, then if we're given that length, then we can find the area of the larger square. And if we're given one of the other two sides, suppose we're given the medium side, well, there's no way that the sum of these two squares, the areas, would add to this one. So the only way to get this side length, if we're given the hypotenuse and the medium side, that leg, is by subtracting, because since this area of the larger square is equal to the sum of the areas of these two smaller squares, then to find the area of this smaller square when given the side length of the hypotenuse and the side length of this leg, the only way to get this is by subtracting the area of this square from the area of this square, and that would of course leave us with the area of the smaller square. So if you're given the length of the hypotenuse, when you do this formula, you have to actually rearrange that. You can either rearrange it algebraically at the beginning, or you can just substitute in the values and then do the subtraction, but you should always start with the regular Pythagorean theorem. And so if we know that we're looking for this side length of the triangle, we need to find that area of the shortest side, the area of the smallest square. So we're going to take the area of the largest square, we're then going to subtract the area of the medium square, and then that's going to result in the area of the smaller square. And then once you get the area of the smaller square after you do the subtraction, then we'll be just taking the square root of that, which will then give us the side length of the shortest side of the triangle. Okay, and same thing would go if we were given the hypotenuse and the shortest side. Again, we would be subtracting the area of the smallest square from the area of the largest square to get the area of the medium square. So I always suggest, when working with Pythagorean theorem, always think of it as squares, and you're finding the areas of those, and knowing that the areas of these two, the sums of these two areas add up to this one, then if you're ever given a situation where you have to find the length of the medium side of the triangle or the short side, then you just subtract the area of whatever square you do have from the area of the largest square, and that will then automatically give you the area of the smaller square, and then you take the square root. So that is the development of the Pythagorean theorem, and a couple tips and hints as to how to solve the different types of problems that would come about by using Pythagorean theorem.